In this lesson, we are going to look at the relationship between f of x, f prime of x, and f double prime of x. Now, if we're given f prime of x, we can figure out some information about f of x and also f double prime of x just by looking at the graph of f prime of x. In this first example, we are given the graph f prime of x, and we're looking for information about f and also about f double prime of x. Now, f prime of x consists of 3 line segments and a semicircle. This first question is asking us to find the critical points of f. By looking at our f prime graph, these are going to be our x-intercepts because we need f prime of x is equal to 0 to find the critical points. And this occurs at x equals -4 and x equals 0 and also x equals 6. So these are all these points over here. In the next question, we want to find the x-coordinate of each relative extrema, so local extrema of our f, and we're going to label these as max or mins. In order for us to have relative extrema, we do need the critical point. So we did find that in the first part of the question. But take a note, we're not going to consider x equals 6 because it ends on the right of x equals 6, so we can't have a max or min there. So only possible max or mins are at -4 and x equals 0. Now we're going to see what happens in between x equals -4. If you look at the sign of f prime, this is positive. These are positive y values. And then on the right side, we have negative y values. So f prime changes from positive to negative. And if we think about the picture, it's going to look like this. Positive and then negative. What's that going to give us? This is going to give us a local max at x equals 4. Now looking at x equals 0, we're going from a negative y value for f prime to a positive y value. So f prime changes from negative to positive, and if we think about how increasing decreasing looks like, that is this, from decreasing to increasing. So we have a local min at x equals 0. So to recap what we've just done, when we're reading the y values of this f prime graph, we're also looking at the increasing decreasing of f. So if you want to look at the values of f prime, these are your y values. And if we want to look at f double prime, which we're going to do just in a bit, this is going to be the slope of your f prime graph. So now we're going to look at C. We want to know when f is increasing and decreasing. Very similar, so if f prime is positive, we know f is increasing, and if f prime is negative, then we know f is decreasing. So that means f is going to be increasing between -6 to -4 because our y values are positive here, and also between 0 and 6. So f is increasing over -6 to -4 and 0 to 6. And this is because f prime of x is greater than 0. It's positive. Now we know f is decreasing when f prime is negative. And this occurs between -4 to 0. looking at the next question, we want to find points of inflection. So your points of inflection is going to occur when you change your slope of f prime. So if we look at x equals -2, we went from a negative slope to a positive slope. This is where your inflection point is going to be then, x equals 2. Another place when that happens is at x equals 4. We went from a positive slope for f prime to a negative slope for f prime. So we have x equals -2 and x equals 4, since f double prime changes sign at those places. Now we want to look for concavity. So you want to know when f is concave up and concave down. That means we're going to look at the double derivative or the slope of f prime. If the slope of f prime is positive, that's concave up. If the slope of f prime is negative, we know it's concave down. So let's look for concavity when we're concave up. So we're looking at positive slopes for f prime. We have positive slopes between -2 to 0 here. This is a positive slope. We also have from 0 to 2. So then when we describe this, that's -2 to 0, and then 0 all the way to 4. So that part's a positive slope, and this part is a positive slope. And that's because f double prime of x is positive. Now looking for concave down, we're now going to look at the slopes that are negative in f prime. So we have that from here, and we also have it here. So that's -6 to -4, and -4 to -2, and then 4 to 6. And this is because f double prime is negative. Our slope is negative for f prime. In the last question, we are looking for the equation of the tangent line to f at x equals -2. We are given the point already, that's -2, 4. The only thing we're missing is the slope. And we're looking for the slope at x equals -2 for f. And we can just read off our f prime graph to do that. That's this point over here. So x equals -2, we're going to get a f prime value, a y value of -2. That is our slope for f. Now we put it all together in our equation. Y minus the y value is equal to your slope multiplied by x minus your x value, minus -2 is +2. And that's it for that question. So now we're going to go on to the next page and summarize everything that we've done. So these are your guidelines for finding information from the graph of your derivative graph of f prime. If you want to find critical points of f, then you're going to look at points whenever f prime touches the x-axis or has a point where it is undefined, because we're looking for f prime of x is equal to 0. For relative maxima, this happens when the graph crosses the x-axis from positive y values to negative y values, because you're going to get increasing to decreasing around your critical points. And this creates a local maximum. Now for the local minimum, this happens when the graph crosses the x-axis, but from this time it's negative y values to positive y values. And this creates a minimum. Then f is increasing when the graph of f prime of x is above the x-axis, because the slope of f is positive there. So that means f is increasing. Now f is decreasing when the slope of f is negative, and this happens when f prime of x, all those y values are below the x-axis. Your points of inflection, they occur when the slope of f prime changes from positive to negative, or when f prime changes from negative to positive. And then we know that f is concave up when the slope of the graph of f prime is positive. So you're looking for the slope of f prime to determine concavity. Now, when the slope of the graph f prime is negative, then you know that's concave down. And then lastly, if we're looking at the slope of the original function at a point, the y value of the graph of f prime gives you the slope at that same x value. For example, if we're looking at the point 1, 2 in f prime, this means your slope is 2 when f is equal to 1. Okay, so this is the summary of how we are able to find the information from the f prime graph to information about f. Now we're going to use this information to do the next question, and I want you to try it yourself first, and then we're going to go over it together on the next page. So do this question on your own first, and then press play when you're ready. Okay. So in this next example, it's fairly similar to the first one. We just want to find the critical points. And this is, again, remember every time you cross the x-axis, or when f prime of x is 0, this is your critical point. So this happens at 1, 4, and 6. Now we want to know when f is increasing or decreasing. So we're looking for when f prime is positive. This occurs between 0 to 1, and then 4 to 6, and then 6 to 8. And for decreasing, this only happens between 1 to 4. That's when f prime is negative. Now looking for local max and min, we want to see when f prime changes from positive to negative. So we're going to have a max at x equals 1 because on either side, we're going from positive to negative. And then for our relative min at x equals 4, we're going from negative to positive y values. If you look at x equals 6, we don't have anything there because f prime doesn't change signs, positive to positive. Now for the points of inflection, we have to see when f double prime, so the slope of f prime, changes sign. This occurs at x equals 2 because your slope here is negative and then your slope here is positive. And then looking again at 4.75 around this area, positive slope to negative slope there. And then for 6, again, negative slope to positive slope. So those are your different points of inflection. If you want to find the intervals that f is concave up and concave down, we look at the slope of f prime and see one is positive or negative. So our slope is positive between 2 and 4.75. So our slope is positive here, and it's also positive between 2 and 8. We have concave down whenever the slope of f prime is negative, and that is going to be from 0 to 2, and then also from 4.75 to 6, around here. And then the last question, we are given a g of x, and we want to find g prime of x. So we're going to take the derivative of x squared, and then f of x, and then evaluate at x equals 2. So the real problem with this one is f prime of 2. We can find f prime of 2 by reading off our graph. And f prime of 2 should give us negative 2, according to the graph. So it's right here. So we're going to replace f prime of 2, which is negative 2, and overall your answer should be 6.